Okay, Math 10, starting out for 2018 with a little different curriculum. This is the first lesson, and I'm just getting to the meat and potatoes of the lesson here. We already told you what factors were of a number. We told you what a prime number was. Now we're going to put them both together. So if you missed that part, just look back in the previous few pages for explanation. But what we want to do is prime factorize a couple of numbers. So there's a couple ways we can do this. First method is a division table, which isn't as popular, but when I give you a quiz or a test, I'm just going to say prime factorize it. I don't care which of these two methods you use, so some kids will like to use this table. So you start with a number 48, okay? You take out a prime number from 48. This person took out a 2, which was a good choice. Cut the number in half. Now we have 24. Okay. Next prime number to take out of 24 is another 2. Then we got 12. Take out another 2. Now we have 6. Take out another 2. Now we have a 3. The only thing we can take out of there is a 3. That's a prime number. And you keep going until you get a 1 here on the bottom. So this is now prime factorized. What this means is 48 as a number is 2 times 2 times 2 times 2 times 3. And it doesn't matter what order this is in. If you saw you could have taken a 3 out first, that's okay. Any combination of these numbers is correct. Tree diagram, more popular. Okay, start with the same number 48. You might remember in your multiplication table that is 6 times 8. So there's a couple of branches of the tree, if you will. And you keep going until, again, they're all prime numbers. So 6 is not prime, but it is 2 times 3. So these branches are now done. 8 is 4 times 2. This branch is done, okay, but 4 is not prime, so keep going. 4 is 2 times 2. So again, 48 is 2 times 2 times 2 times 3 times 2. Exact same numbers as we had here with the division table. We could write it out to make it a little more clear for the teacher, so we can read it and actually give you a mark for that if you're incredibly messy. And if you're really good, you'll notice you got 1, 2, 3, 4 2's, so we could write it like that. Okay, but that's not completely necessary, only if we ask you to do it. Okay, that's using powers. So a couple more examples. Okay, so again, we're going to show you both ways to do this. Here is a big nasty number, 33,250. And this is kind of like, they would never do this in the old curriculum. Here's the answer. We're telling you what it is, but you've got to show how we get that. Okay, so tan 2 here, he likes a division table. He sees this as an even number, so he's going to take a 2 out. Okay, now division table, I just want to note, you might say, okay, 10 goes in there, but you can't do that with a division table. These have to be prime numbers, okay? You can't take a 10 out, because then you got to split that down into 5 and 2, and then it's not really a division table. It looks like a hybrid of a division table and a tree diagram. Okay, so 2. We took 2 out. We take half of that. And if you could do that in your head, wonderful. But I'm going to allow you to use one of these, so feel free just to make sure you don't make a mistake. If I take half of that, I get 16,625. Okay, now hopefully you see that you can't take a 2 out of there because it's an odd number, ends with a 5, so the most logical thing to remove as far as a prime number goes is a 5. So take a 5 out of that, and we've got 3325 left. Next, well, take out another 5. 665. And again, we keep going until we get a 1 at the bottom. Take out another 5. 133. Now I can't take out a 5, obviously. Now you come to the point where, how's your numeracy? How's your number sense? What goes into 133? That's divisible by what? This is trial and error. It's not an even number, so you're not going to try 2. The most logical thing to try then is the next prime number. Let's see if 3 goes in there. It does not. Next number. Well, obviously if 2 doesn't go into 133, neither will 4. 5 doesn't, because it doesn't end with a 5 or a 0. Not 6. What's the next prime? And you move up in primes until you find one that goes in. Aha! 7. Goes into 133 19 times. The only thing that goes in 19 is 1 and 19. That again is a prime number, but keep going until you get a 1 down here. Okay? So this is the answer. 33,250 is a product of 19, 7, 5, 5, 5, and 2. Okay? So if I do the tree, I better get these same numbers or I did something wrong. They're leading us into Craig's solution here. He wants to take a 10 out. Awesome idea. But don't leave it like that. That's not correct because this isn't a prime. You got to keep going until they're all primes. And if you take a 10 off, just drop a 0, right? Divide it by 10. Now what? Well, I think we've already done this. I want to take a 5 out of there. And then think smart, right? If I take a 5 out there, I'm going to have a big number here, and then it might get a little bit cluttered in the middle if I've got branches going in the same direction. So the more you do this, the more experience you have into how to make it legible for the teacher to give you a mark. So I'm cheating here. I know that if I took a 5 out, I get 665. Okay. Again, if I take another 5 out, I get 133. And I found that that was a product of 7 and 19. And this is now done. Every one of these are prime numbers. So again, 33,250 is 5 times 2 times 5 times 5 times 19 times 7. Doesn't matter what order it's in. But that is now prime factorized. Now it's not a bad idea to just write it down here. If I wanted to be real good, I'd go, I have 3 5s, that's 5 cubed. I got a 2, I got a 7, I got a 19. That's the answer. I clearly see that. Okay, if you're messy, again, I encourage you to do that so we can actually see the answer. Okay, that's lesson number 1. There's the questions you want to do in that brand new green workbook. That's it for the first lesson.